the physics of fast, how acceleration actually works in team sports. Speed is one of the most important and most misunderstood qualities in team sport. I'm Matt Jones from PEMS Performance. Today I'm going to break down acceleration from first principles. Not drills, not cues, the physics that actually determine whether an athlete gets faster or not. Because if you play a team sport, performance breaks down into two things: your ability to move fast and what you can do when you get there. It's sprinting and ... That second part changes depending on the sport. A pass, a tackle, a shot, contact. But the first part doesn't change. If you get better at accelerating, you get better at sport. Around 90% of acceleration happens within the first 20 meters in track and field. In team sports, most sprints are even shorter, on average 10 to 15 meters. That means acceleration is not a phase of speed when it comes to team sports. It is speed for most athletes. If you improve your acceleration, performance improves. It's that simple. I spend a lot of time talking about physics with athletes, mostly because physics doesn't care about opinions. If we go right back to Isaac Newton, his first law tells us that an object at rest stays at rest unless acted upon by an external force. That means if you want to start sprinting, nothing happens unless you apply force. Efficient acceleration feels heavy, it feels deliberate, it feels powerful. One of the biggest mistakes athletes make is trying to move too fast, too early. They tap the ground, they spin their wheels, they don't actually go anywhere. Acceleration is about pushing the ground away violently enough to displace your mass forwards. Newton's second law tells us that force equals mass times acceleration. Or to say it another way, acceleration is your force divided by your mass. If you're a bigger athlete, you don't get a free pass. You need more force to move at the same speed. And here's the catch. For every step you take, you have less time to apply that force. And that's why strength training really matters, but only to a point. At some stage, force has to be applied quickly. Under time pressures, in sprint-specific positions. So that's why sprinting, plyometrics, and high velocity work are non-negotiable if you want to be fast. And Newton's third law is where those mechanics actually start to matter. Most of you have probably heard of his third law: for every action, there's an equal and opposite reaction. The direction you apply force determines the direction you travel. Early acceleration is dominated by horizontal force. The more horizontal force you can produce relative to your body weight, the faster that you can accelerate. At max velocity, that changes. Force becomes more vertical to maintain speed. But acceleration and max velocity are different problems. Today, we're just focusing on that acceleration. One of the simplest and most useful principles in sprinting is this: your shin is your compass. I think I originally stole that from Jonas Dodo, if I remember rightly. He was a speed coach. But where your shin points is where you apply force. Where you apply force is where you travel. Positive shin angles allow backwards force production. Backwards force is what moves you forwards. Vertical shins produce vertical force. That's max velocity, not acceleration. Biomechanics does the work for you if you get into the right positions. And that if is vital. Once you project forwards, acceleration becomes about repeatedly attacking the ground down and back. That shin stays pinned in place, the hips extend, and the hips project you forwards. That's how you displace mass. It's a simple concept, but very, very hard to execute. Acceleration is about big shapes. Arm action doesn't magically make you faster, but poor arm action will absolutely slow you down. Your arms set your rhythm. They resist rotation of that lower body. They coordinate what the lower body is doing. If the upper body is chaotic, the lower body never reaches full force output. And this is where team sports differ from track. In track, acceleration's clean. There's no decisions, no opponents, no chaos. In team sports, you have to see what's on the field. You have to react to stimuli. You have to adjust posture. But the physics don't change. You still need to learn the rules before you can break the rules. 0 to 10 meters is still push dominant, no matter where you're pushing, whether that's on a track or on the field. The more force you can apply, the faster you go. Speed itself is full of paradoxes. You need high force, but you also need relaxation. The fastest sprints in the world look effortless. The more you tense, force, and chase speed, the slower you actually get. We want violent intent with relaxed execution. When I coach acceleration, this is what I'm looking for. Forwards first. Project your hips, travel somewhere. Ultimately, this is the big thing when it comes to acceleration. We have to go forwards. Your shins dictate the direction that you travel. We need to attack down and back on every single step. We want to apply that force down into the ground and backwards to propel ourselves forwards. We need stiff foot contacts, no energy leaks. That foot's a hammer, the ground's a nail. We need patience. We don't want to rush positions. Take your time, project, and allow yourself to rise naturally when you are accelerating. And relax. We don't want to waste energy. We want to be efficient when we're making these movements. This is a quote from James Smith here. Ultimately, if you accept that sprinting is fundamental to sport, then you have to accept that developing it is a non-negotiable. If it matters to your role, then training speed itself matters to your success on the field. No matter the sport, no matter the position. If you sprint, you should be training speed every week. So hopefully this gives you a clear framework for how to think about acceleration, not just what drills to copy to get faster. And if you found this useful, please like, subscribe, and give me a follow here on YouTube or on Instagram at PEMS_performance for more content on sprint training and performance. Thanks.